great pleasure to meet again. Like each year, we are here with some articles from Technical University, Civil Engineering, and also the Romanian General Association of Refrigeration. These two articles we wrote with a group from our university, my PhD students, Mioara, VINCERIUC, and Ioan ZABET. I will present both of them. It's about first air-water heat pump modeling, and second, it's about ecological analysis of three types of refrigerant. First article, I told you it's about the heat pump we have in our laboratory, and we try to show in this article a modeling study for R1234A using this refrigeration system, using some softwares and also using some data acquisition, some equipments, ClimaCheck, and also using RefProbe and engineering equation solving. You have here the, some properties of this refrigerant, and you will see later some comparison with the other refrigerants. In these slides, we can see the components and this air-water heat pump. You see the compressor, evaporator. Here is the condenser, helical tube condenser, and we have also an internal light tube heat exchanger because sometimes we are connected with solar collectors or boilers. For modeling, you have here introduced parameters like evaporating, condensing pressure, external air temperature, water temperature inlet and outlet, temperature inlet and outlet evaporator, refrigerant temperature inlet and outlet evaporator, refrigerant temperature inlet and outlet compressor, wet air temperature and mass flow for water condenser, mass flow air evaporator, and water specific heat content. As resulted parameters, we have evaporator and compressor refrigerant mass flow, volumetric ratio, isentropy, compression, global coefficient of transfer, evaporator, performance coefficient for cooling, condenser and evaporator ratio, cooling power, condenser thermal power, compressor volumetric ratio, condenser water thermal power, air cooling thermal power, and many others. For mathematical model equation for refrigeration system, you have here equation for condenser with for refrigerant and water, evaporator, refrigerant water, compressor, also heat transfer coefficient for condenser and evaporator, and finally the coefficient of performance. In this slide, we can observe the value of coefficient of performance for heating and cooling using ClimaCheck interface. Here you see there are also other data, but this was for just to show an example of this interface and the calculation of the coefficient of performance for heating and cooling. And also you have here some experimental data. Performance preliminary coefficient for heating and cooling cooling versus ambient temperature, and this was until we entered the regime. Also in these two figures we can see how we measure the cooling COP versus cooling capacity and heating COP versus compression ratio. And we see here some values for different types, and this was more an energy efficiency analysis in this article, and the most important is to see that it was a validation between experiments and measurements, 3% accepted technical error. And as we see here in these two figures, the heating and cooling COP experimental measure versus calculation for this model for this refrigerant. This was my first presentation, and the next one is in connection with this one. As I told you, this second presentation is about ecological analysis, a comparative refrigerant study between that refrigerant 134A and 1234YF and two mixtures, MV3T and MV3TM. For this point of view, we try to respect EU regulation, F-gas first of all, and international legislation. So we try to find a solution and with two mixture, these two mixture MV3TN and MV3T. I already presented in some articles one of this mixture. We try to replace and to make a retrofit for this heat pump. Now it's working with 1234A. So you can see here the comparative study of these facilities for the coefficient of performance and energy efficiency ratio. And also we make calculations for total equivalent warming impact in respect with 378 standard. The theoretical study analyzed a one-stage refrigeration system, currently works with 134A, and to implement international legislation, it is necessary, as I told you, to retrofit HFC refrigerant with ecological refrigerants, and this, in this study we try to make with these two mixtures, with 0 dP and low global warming potential. I will present some thermodynamic properties and ecological analysis here, and there are some data you will see in next three figures after simulation making an analysis of thermophysical properties, and we observe that the mixture MV3TN has lowest pressure in comparison with other refrigerant. This is an advantage we have taken into consideration. And also, we can observe that first refrigerant has the lowest density comparing with the others. So these two mixtures, after some research, we decided to be a reasonable option for retrofit with this R134A, because there are with very close values, as you see here. These are values very close for MV3TN and 3, almost the same. And also you can show here that the option MV3TN has a lower pressure than the others. That is an advantage. Also, we can see in this figure, as I told you, an analysis, a comparison of heat of vaporization. And again, these two options are very close and very good. Both of them can replace 134A. This you can see the experimental setup, the experimental that we create in our laboratory, Technical University of Civil Engineering, with the support of Romanian General Association of Refrigeration. As I already show you, here is the compressor, here is the evaporator, and also we have the condenser, evaporator, compressor, and condenser. We have here the soft data acquisition, and you can see here a lot of sensors because we made thousands of measurements. We have a lot of data now. I don't have time to show you. And as I told you, this second presentation was more for ecological analysis, and we made comparison between total equivalent warming impact. As you see here, this option has to be the best if we want to replace 134A and MV3TN. And also you have an image here. Of course, 1234YF is the lowest, but this refrigerant has some problems. So we decided finally to use this option in our PhD thesis. So, in conclusion, for environmental perspective of total equivalent warming impact, this option MV3TN has an advantage of lower global warming potential comparison with 134A. And after analysis of thermophysical properties, it could be observed that the mixture MV3TN has low pressure in comparison with the refrigerant of 123YF, this olefin. And the fourth point of view of efficiency, the mixture MV3T has the advantage of higher heat of vaporization than the last one, and also the olefin. I want to show you some images of our activity with our group, our students from Technical University of Civil Engineering, cooperation between our General Association with the private sector at the university, also cooperation with ASHRE, RIVA, UNEP, International Institute of Refrigeration, institutes from UK. We have also projects with that institute. And also some images from our conference, because I went to celebrate and to congratulate the group from Serbia from this 50-year celebration, but also next year we will celebrate 30 years. So you are welcome. As Mr. Piercer invited us, all of you are welcome in Romania again. And maybe some of you visited our country in Clima 2019, where again we presented more than 6 articles with this group. So we try to be prolific and to contribute with our generation, younger generation, and also you have here some images with our ASHRE student branch, Civil Engineering in Bucharest, and some of them are here, and that was my presentation. Thank you very much. I think that it was energy efficiency and ecological presentation.